Welcome to our live training session number 16, part 3. In this video, we're going to take a look at using our drive-by-wire throttle control in order to regulate the horsepower of this engine so that it's going to meet its horsepower to weight ratio in the class it's going to race in. We're going to have a lot to learn, so let's jump into the live training session so we can get started. Welcome back to our live training session here with our Porsche Cayman. Now in the last video, we dialed in our spark timing table, we've dialed in our mass airflow curve for our fuel delivery for idle, part throttle, and full throttle, and we dialed in our variable cam. So we found all of this to be set up, and we see on the dyno screen right now, this is the result of all the tuning that we've done. We made about 330 horsepower and about 300 foot-pounds of torque. So you can see it's nice and smooth, nice and linear, power looks great. Normally, I'd say I'm done here, but this situation with this race vehicle, we have a big problem. It's making too much power. It's making too much power for the racing class. The racing class is based on power to weight. So in this situation, with the way the car weighs, we have a 10-to-1 power to weight ratio. We're gonna find that we have to have about 300 horsepower at the wheels, no more. If the car has more, it's gonna get weight biased and it's gonna be slowing the car down. We want to avoid that. So we need to get creative here and detune the car and come up with a way that we can detune it that's going to make sense. Now we can detune it by pulling ignition timing out. That could pull some power out. We could also go into our variable cam table. If we jump into here, and we could put some overlap on the top end. We know as we were walking the variable cam in and we were increasing them out, every time we started to increase it on the top end of the table, it was losing. It didn't like that. So we could do that. Or the better option here, because this is drive-by-wire, we can go into our drive-by-wire table and start to manipulate the table to get the results that we want. So if we close the throttle, it's going to be flowing less air mass in, and naturally we're not going to make as much power. We're going to have less air coming in the engine, so it's going to just automatically reduce the power. So let's jump into our drive-by-wire here and talk about this. Now this table here is going to be set up already. I didn't touch anything. This is all the way it was in the base session from AEM. We can find this is going to be based on our accelerator pedal position. So we can see the drive-by-wire APP1, and if I give it gas, we can see our cursor here is following along in the table at our breakpoint here of 1,000. Now the engine's off right now, so it's just simply going to go in and go back here and trace through the table of where I'm going and giving it throttle. Now one important thing to note is that this is not necessarily a linear table. If I'm giving a little bit of throttle, we can see my pedal position is 20%, but my plate is 14%. Now I have it, this is dialed back here a little bit, so we don't have too much response, and it's going to be too sensitive if we have it at a 1-to-1 ratio. Now if we have a cable-driven throttle body, that's going to be at a 1-to-1. So if our pedal moves 10%, our plate moves 10%. It's going to have a linear scale from 0 to 100. On a drive-by-wire, we have a tremendous amount of flexibility because we have the ability to go into the table here and specify, even if we're at, let's say, 100% throttle here at our pedal position, our plate doesn't have to be there. We can go in and virtually program this so that our plate can be at 20%, 30%, 50%. It could be at whatever we want. And we can see this table here is based on engine RPM. So we have the ability to dynamically move our throttle plate target here as we're driving around. So on the top end of the table, we could close the throttle and essentially shut the power down if we wanted to. So we have some flexibility here. We're going to be using this in our strategy for going in and keeping us at 300 horsepower. Now, we're not restricted in torque. We can make whatever we want in torque. So my goal here is to keep the top end of the power band, or say the low and the mid range of the power band the same. I don't want to lose the torque. I'll keep my throttle open. But at the top end of the power band, I need to detune this, and I need to close my throttle. But I don't know how much I need to close my throttle. So we're gonna have to do a little bit of trial and error here and figure out throttle opening versus the power it makes. And then once we